clerical and custodial employment categories, but what we don't know, at least as a trend, but we don't know if the difference between clerical and custodial is statistically significant. In fact, all a one-way analysis of variance tells you is that there's at least one mean comparison between the groups that is statistically significant. And at the minimum, you would think that the difference between the lowest mean and the highest mean is statistically significant, different from each other. But you don't know anything else. You don't know for certain if this mean is statistically significant from this one, and whether this mean is statistically significant different from this one. Now, it's actually also possible, which is really interesting about ANOVA, and I'll only mention this very briefly, is that sometimes when you go to do your post hoc testing, none of the differences are actually statistically significant. Not even the largest difference between the two means, and I'm going to talk about that in another video. There's a reason for it, and it's a very it's not a complicated reason, but it's true to the ANOVA. The ANOVA is doing what it's supposed to do, but I'll leave that to doing contrast testing or post hoc testing in the analysis of variance case. Actually, what I'll mention now, I was going to end the video there, is there's a second way of doing a one-way analysis of variance in ANOVA, which has one added benefit to it, and it's in the GLM procedure. You go into ANOVA, analyze general linear model, go into univariate, and you put your salary into the dependent variable, and you put your employment categories into fixed factors, and then you choose options. You put JobCat into the display means, you choose your descriptive statistics, and the important point here is that you can also get an estimate of effect size. Now, this is important. We don't do statistical testing just to find out whether there's a statistically significant difference in means or if there's a correlation that's statistically significant. We want to see that the effect is small, medium, or large, and an effect size estimate tells us that. And I'm not going to click any of the other options here for now, but I'll just point out that there's a homogeneity of test here. But what's missing is that we don't get any non-parametric statistical tests to help us back up our significance values if we violate the assumptions of homogeneity of variance, and or if the data are not normally distributed. And actually they're not in this case, but I'm going to go into that in another video. So I'm going to click on Continue and click OK, and what we get are the same means, descriptive statistics, same means and same standard deviations from the GLM procedure. We get the same test, Levene's test of homogeneity of variance, and we get a similar but a bit different ANOVA table. We get the job category independent variable. Remember that F value of 434.48? Well, here it is here. The same degrees of freedom in the numerator and in the denominator, but the extra bonus is we get something called partial eta squared. Most people in this context would just call it eta squared, and this is a measure of effect size, and I'll do a separate video on eta squared. But briefly, this can range between somewhere between 0 and 1.0, and it's telling us that 64.8% of the variability in salary is accounted for by group membership, in this case job category. That's pretty huge. Nearly 65% of the variability in how much somebody earns is accounted for by what category they're in terms of group membership. And we can see the means here. The means are pretty different from each other, so it's not surprising that the difference is that big. But the difference is big, but it's quite substantial. And we actually get a numerical estimate of exactly what that effect size is in this case. And that's the benefit of doing it in GLM. Otherwise, you're stuck with having to do it with the sums of squares by hand. Why would you want to do that when you can do it in SPSS automatically? All right, well, thanks for listening. I hope you learned something useful about ANOVA in this video.